Hello friends, myself Dr. PINAL D. Patel will discuss about the errors of vernier calipers and micrometer screw, that is the zero positive and negative errors of this instrument. Vernier calipers and micrometer screw ની શૂન્ય ધન અને ઋણ ત્રુટિ from the chapter 1, that is unit and measurement, and from our subject engineering physics. Why to measure the error? See, if we get the answer and if the answer is wrong, if there is a calculation mistake, then you cannot change the answer or your answer will be wrong. But if there is a error in the instrument, then you can nullify that particular error. You can understand the types of errors. Sometimes why these errors are occurring. They are nothing but due to the wear and tear in the screw gauge or in the alignment of the vernier caliper. Okay. Basically, errors we can have in two major issues. Okay. What are the errors of vernier calipers? A very simple way to explain the errors. Okay, before you use the apparatus to find any dimension, તમે કોઈ બી માપન માપતા પહેલા વર્નિયર નો ઉપયોગ કરો તો what is the checkpoint is that both the jaws should be closed and the zero of the main scale and zero of the vernier scale should coincide. જ્યારે હું કોઈ બી પદાર્થનું માપ માપું છું તો મારે એ વસ્તુ ધ્યાનમાં રાખવી જોઈએ કે બંને જોઝ બંધ હશે ત્યારે મેઇન સ્કેલનો ઝીરો અને વર્નિયર સ્કેલનો ઝીરો કોઇન્સાઇડ થવા જોઈએ. જો એ ના થાય તો there is some problem in the instrument. ઇન્સ્ટ્રુમેન્ટનું અલાઇનમેન્ટ ખસી ગયું છે or it has been damaged. Okay. What is the case of micrometer screw? Same way, before placing the object between the screw and the anvil, what you have to check is the baseline and the zero of the circular scale and the zero of the main scale should be in a straight line. As seen in the figure, the baseline and the zero of the circular scale should coincide. That is the checkpoint before taking the reading. If this is not the case and you are taking the reading, your readings won't be accurate. જો આ કેસ નહીં હોય અને તમે રીડિંગ લેશો તો તમારા જે બી આન્સર્સ આવશે એમાં ત્રુટિ હશે. It won't be a perfect answer. Though you have taken it very precisely, તમે ધ્યાનથી રીડિંગ્સ લો છો, accurately લો છો, but there is some problem in the alignment or in the damage, I can say that, or it has been શું કહેવાય, હું એવું કહી શકું કે વધારે વખત યુઝ કર્યું છે જેના લીધે માઇક્રોમીટર સ્ક્રૂ નું અલાઇનમેન્ટ બગડી ગયું છે યા એ ખરાબ થઈ ગયું છે. So that can be nullified. How to do this? We will see it in this particular video. What is error? A simple answer. It is the difference between the, as I said it earlier in the video of types of error, it is the difference between the actual reading and the I can say measured reading. That is error. But in other words, if the zero mark of the vernier scale does not coincide with the zero mark of the main scale, this is called as error. There are three types. Zero error ठीक है, but positive error, negative error, धन त्रुटि, ऋण त्रुटि. One by one we will see it. What is the zero error of vernier caliper? As seen in the figure, this is the main scale and this is the vernier scale. I have not drawn the whole vernier, but which are the two scales that you have to keep it in mind before checking the error? That is the zero of the main scale and the zero of the vernier scale should coincide each other. મુખ્ય સ્કેલનો શૂન્ય અને વર્નિયરનો શૂન્ય જે બંને એકબીજાને બંધ બેસતા હશે, so this is the ideal condition to take the reading. આ condition હોય અને તમે રીડિંગ લેશો તો તમારા રીડિંગમાં કોઈ એરર નહીં આવે, સિવાય કે તમે કોઈ એરર ક્રિએટ કરો. ધ ઇન્સ્ટ્રુમેન્ટ ઇઝ ઓકે, there is no problem in the vernier, but if this is not the case, જો આ બંને coincide ના થાય તો શું? There are two possibilities. Either the zero will be moving away from the main scale or ahead or behind. હું એવું કહી શકું આગળ યા તો પાછળ zero ખસી જશે. કોનું? વર્નિયર સ્કેલ. As seen in the figure, if the positive zero, in the case of positive zero error, when you bring both the jaws, you see that the zero of the vernier scale is ahead of the main scale. Here it is, this yellow part of the vernier scale. આજે yellow વાળો માર્ક છે zero દેખાય છે અહીંયા. ઓકે, વર્નિયરના બંને જોસ બંધ હોય ત્યારે જો વર્નિયરનો શૂન્ય મુખ્ય સ્કેલના શૂન્યની જમણી બાજુએ હોય, that is called as positive error, ધન ત્રુટિ. GTU માં પૂછાય તો you have to write this as a definition. Draw this figure. ફિગર દોરી દો. કયું ડિવિઝન મેચ થાય છે? ઝીરો મેચ નથી થતો તો કયું ડિવિઝન મેચ થયો? ઓકે, ઇટ ઇઝ ધ થર્ડ ડિવિઝન. Then it is a simple thing. What you have to do is multiply this with the least count. 3 into least count. છે બંનેમાં I have written in both the languages. 3 multiplied by 0.01, 0.03 cm. And what you have to do in the form of correction is you have to add, as the error is positive, you have to subtract it from the answer. 0.03 ને મારે આન્સર માંથી માઇનસ કરવું પડશે. Let's suppose I have taken some reading in the form of or I am finding the diameter of a sphere. The diameter comes about 2.35 centimeter. So what I have to do is, this is not my final answer because the instrument was having an error. Both the zeros were not coinciding. એટલે મારે શું કરવું પડશે? What I have to do is 2.35 minus 0.03. This will give me the answer, which stands to be 2.32 centimeter. This is my correct answer. 2.35 is not the right answer because this was the dimension of the sphere without checking the error. I have not checked the error. મને ખબર નથી કે બંને ઝીરો મેચ થાય છે. તો બંને ઝીરો મેચ થતા હોય તો આન્સર સાચો છે, પણ એવું નથી કન્ડિશન. કન્ડિશન કઈ હતી? તો કે વર્નિયરનો ઝીરો જમણી બાજુ ખસી ગયેલો. It was moving on the right hand side or ahead of the main scale. So I have to do this. I have to find the matching division. ત્રીજું division match થયું, multiply by the least count and minus it from the answer. Okay. What is the second error? If it is not ahead, so क्या हो सके? Simple, खबर पड़ी गई ऐसे बताने. Okay, it can be on the back side or गुजराती में कहूँ तो डाबी बाजू. Okay, in GTU, once again write the definition, draw the figure. कયું division match થાય છે? તો કે 8. Total, the 8th division is matching. It's not the 8th division error. So what you have to do is total division minus the matching division, which comes out to be 2, multiply by least count and the same method. As the error is negative, what I have to do is I have to add it into the answer. The same way, મારી જો error answer ફરી પાછો 2.35 centimeter હતો તો આ સાચો નથી. કેમ? Because both the zeros were not coinciding each other. એટલે મારે શું કરવું પડશે? તો કે I have find the error. મેં error શોધી કાઢી છે. કેટલી છે? કે 0.02 centimeter ની. Error negative છે. I have to add it to my measured and I will get the final answer, which comes to be 2.37 centimeter. Okay, this is nothing but the types of error in the case of vernier caliper. Okay, both the zeros are not matching. What can be the condition? Either the vernier zero will be on the left hand side or the vernier zero will be on the right hand side. If it is left hand side, negative error. Right hand side, positive error. Error positive હોય તો correction માં minus કરવું પડે. Error negative હોય તો correction માં addition કરવું પડે. Same way, what are the errors of micrometer? Same, as I said it earlier, before placing the object, the circular scale 0 and the baseline on the main scale should coincide each other. That is the zero error. જો વર્તુળાકારનો સ્કેલનો શૂન્ય બેઝ લાઇનના શૂન્યને બંધ બેસતો હોય તો તેને શૂન્ય ત્રુટિ કહે છે. If this is not the case, what can be the cases? Baseline will be the reference mark to find the errors of a micrometer screw. Baseline ને આપણે ધ્યાનમાં રાખીશું. या तो जीरो नीचे जतुं रहेशे या तो जीरो ऊपर जतुं रहेशे. कोनु? सर्क्युलर स्केल. इफ द सर्क्युलर स्केल जीरो इज बिलो द बेसलाइन, नीचेनी बाजू होय तो तेने ध्रुव त्रुटि कहे छे. राइट द डेफिनेशन इन द एग्जाम, ड्रॉ द फिगर एंड व्हाट आर द डिविजन्स दैट आर मैचिंग. कयो डिविजन मैच थाय छे? काउंट इट मैन्युअली. जीरो मैच ना थयो, ओके. फर्स्ट नो. सेकंड इज मैचिंग, मल्टीप्लाई बाय लीस्ट काउंट. The error is of 0.02. Here I already have written this. As I said it earlier, if the error is positive, you have to subtract it from the answer. Suppose my answer is 8.81 mm. I will subtract, that is 0.02, which was my positive error. So in the form of correction, I have to subtract it, and errors will be of about 8.79 mm. What is the matching division? 2 multiplied by least count. I have shown in both the languages. You can see it clearly. Okay. What is the next condition? It will be above the baseline. તમે જો માઇક્રોમીટર સ્ક્રૂ ને કમ્પ્લીટ બંધ કરો છો અને જો સર્ક્યુલર સ્કેલ નો ઝીરો બેઝ લાઇન ને ટચ નથી કરતો, ક્યાં જતો રહ્યો? તો કે ઉપરની બાજુ. It is moving above the main scale, above the baseline of the main scale. This type of error is called as negative error. Same way, writing in the exam, write the definition, draw the figure. What is the matching division? Count it manually. 0, 1, 2, 3. Don't make a mistake in exam. This is 45, 46, 47th division is matching. સાચી વાત છે. ઘણા છોકરા એવું કે એક્ઝામમાં સાહેબ 47. This is not 47. Division coinciding is 47. But what is the displacement of the division? કેટલા division 0 ખસી ગયો છે? તો હું એવું ના કહી શકું 47 division ખસી ગયો. It is displaced by 3 division. Simple. Don't see the reading. Reading ને consider ના કરશો. 0 કેટલો ઉપર ગયો, 0 કેટલો નીચે ગયો. So here it is 0.03 mm. As it is negative, I will add it to my final answer. 1.79 plus 0.03, which will come about 1.82. Error negative, correction positive. Error positive, correction negative. A very simple way to write in the exam is draw the figure, give the definition, and multiplying with the LC. The matching division multiplying with the LC. That will give you the error. The correction, I have, for your explanation, I have written that this is nothing but I have to add to my answer. Once the exam, if you are not able to write it, no issue. Just you can say there is an error of 0.03 mm. So I have to add to my final answer. Clear? As usual, at the end of the video, I am giving you the questions which are asked in the exam. It's a very important question. I can say that which is there in the exam every 6 months. The exams which are there explain zero positive and negative error of vernier calipers. Individual error is asked as a 3 marks. Explain zero positive and negative error of micrometer screw with proper diagram. Okay. Thank you.